Hi all. Today's LeetCode Daily Challenge problem is count vowels permutation. This is a hard problem as per LeetCode. Okay. Looks like I haven't solved the problem. Yes, I haven't. Okay. So the problem states that we are given an integer n. We are required to count how many strings of length n that can be formed under following rules. The rule is all the characters must be a lowercase vowel. Each of the vowel A may only be followed by E may only be followed by A or I may not be followed by another O may only be followed by I or U may only be followed by A. Since the answer can be too large, we are required to return the result with modulo 10 power 9 plus 7. This is a well-known prime number. Yeah. Okay. So if we see it, it is having a overlapping subproblem and optimal substructure. So if we already have answer up to ith index for each of the character, we can get the result for I plus 1th character for each of the character. So actually, we do not need to deal with the index I itself. We only need to consider the ending character result ending result for the string that ends with a particular character, and finally we will sum all the result and get the answer. Okay, so since I already mentioned it can be solved using dynamic programming approach, obvious approach would be top down approach where we can recursively call for all the characters which will be followed. Yeah, so another approach will be bottom up approach. Bottom up approach has lesser space complexity. Actually, space complexity will remain same, but since it is having lesser recursion overhead because there won't be any recursion, so bottom up approach executes a bit faster than top down approach. To convert the problem into bottom up approach, we can see the problem in reverse order. So since we are given that what all characters will be followed by will be followed by something. Okay, so we can reverse it like uh, to which all characters this particular character will follow. What I'm saying is, suppose the previous ending index is sorry previous ending character was for a particular result. Will A be the next character or not? Similarly, will A be next character of U or not? Like that. So, okay. So to convert it into DP approach, we can just assume that A, E, I, O, U represents indices 0, 1, 2, 3, 4. Okay. So A maps to 0, E maps to 1, I maps to 2, like that. And we can Okay, we can also see that there is no need of using the indices itself. We can just have current result for each of the character and next result for each of the character. Okay, now let me explain a bit how the following character. So how the follow relationship will look like before actually starting the actual implementation. So we can see that A can be next character of E, I, and U. Okay. E can be next character for a string ending with A or I. I can be next character for a string ending with A. Wait. Okay. I. Okay. Sorry. E and O. So these two characters will be the previous characters for I. O will be for O. We can see that only I is a valid character. For U, O is the only valid character. Okay. Now we have, okay, let me just go declare it globally, because writing 10 to the power 9 plus 7 every time will be unnecessary, and it's also bad practice to use constants everywhere. So let's define it as final. Yeah. I'm declaring it as long so that in case there is an overflow, it will do the computation. It will do automatic typecasting to long for any of the calculation involved. In case we are using, actually, I will be using long for all my uh, computation, and finally I will typecast it to int before returning it. Okay, now it should be obvious that if the string is having only one length, any of the character can be starting and ending. Basically, for single character string, the any of the character can be a valid string. String with any of the character can be a valid string. So result for length 1 will be 1 for any character, and subsequently we will calculate using those results. Okay, so dp of I equal to 1. Sorry, 1. Initially it will be 1. Sorry, it should be 5 only here, because I'm not going to deal with actual indices. Rather, I will be calculating a result for individual characters. So string ending with A, string ending with number of strings ending with E, number of strings ending with I or U, like that. So it is only 5. And now for subsequent indices, I equal to 1 to I less than n, I plus plus. Here we will have another variable called next of length 5, because first I will calculate the next result and assign it to dp array. So next will be equal to new long 5. Now next of 0 will be, okay, so for calculating next array I'm using dp array, and finally I will assign it like dp equal to next. So here it will be dp of 1 plus dp of 2 plus dp of 4 modulo mod. Why it is like that? Because e maps to character, sorry, e maps to indices, index 1, a maps to index 0. Let me just write it down here. Okay, so it will be easy to see through here like this. Next of 1 equal to dp of 0 plus dp of 2 mod next of 2 equal to dp of 1 plus dp of 3 modulo mod next of 3 will be just dp of 2. Wait, here I did miss one thing. Here I should also be here. Basically you can follow I as well. Yeah, so here I may not be followed by another I. So here it should be I as well. Next of 4 will be dp of 2 plus dp of 3 modulo mod. Now finally, okay, individually each of these are defined as long. So if we add 3 times, add integer 3 times, uh, it may cross the integer upper limit, but since it is defined as long, it will it is fine to do like this. Suppose if I had defined it like int, then I would have to do additional modulo mod here. Okay, now finally I will calculate the result by summing all the results for uh, individual characters that has the result for a e I o u respectively. So for that, answer equal to, let me initialize as 0. Okay, for int I equal to 0, I less than 5, I plus plus. Here we have answer plus equal to dp of I, and since answer is also defined as long, it is fine to do like this because the dp contains values less than 10 to the power 9 plus 7. So 5 times 10 to the power 9 plus 7 will be will still be in long upper limit. Now answer modulo equal to mod, and finally we have to return the result. We have to return the result as integer, so we have to typecast that to int answer. Let me run the code first. Let me test for one more test case here just to be sure. Okay. Yeah, it works. Let me submit it. Yeah, it got accepted. Thank you all. Yeah, please like, share, and subscribe if it is helpful to you. Bye.